Solving one-step equations. I have right here a scale drawn at the top of this picture, a rather rudimentary scale. And on the left side is a red circle and an orange square. And on the right side, I have 3 red circles. And we can see that right now the scale is balanced on either side. But what if I want to know what the value or the weight is of this orange square in terms of red circles? Well, I would need to get the square by itself. Right now, though, I've got this red circle right next to it. So go ahead and think about how can I get that orange square alone on the left side and still keep my scale balanced? So hopefully you come up with this idea. If you remove a red circle from the left side, but you still want your scale to be balanced, you've got to remove a red circle from the right side as well. Whatever you take from the left side, we would have to take from the right side. If you have a scale and you add something to the left side, you would need to add the exact same weight on the right side. And here we can see that 1 orange square is worth 2 red circles. So the same is going to be true for variable equations. So these are only one-step variable equations. Let's look at this first example. It says x plus 3 equals 7. If I want to isolate or get alone this x variable, I need to get rid of the plus 3 that is next to it. And the opposite or the inverse operation of plus 3 is just minus 3. So if I subtract 3 from the left side of this equation, I would need to subtract 3 from the right side of this equation as well. And let's see what that gives us. So I'm going to bring down my x variable. I didn't do anything with that. And then plus 3 minus 3. Those inverse operations cancel each other out. And then I am left with equal sign 7 minus 3. Well, 7 minus 3 is just 4. And here I can see that my x variable is equal to 4. Go to your next equation. It says 2x equals 10. 2x equals 10. So what I want to know is what math operation is happening with this 2 and the x value. I don't see a mathematical symbol in between them. And hopefully you remember from your pre-algebra that the 2 and the x are being multiplied together. They're being multiplied together. When you see a number and a variable side by side like that, that's multiplication. Well, what's the opposite or the inverse of multiply? And that's just divide. So I am going to divide both sides of my equation by 2. And of course, 2 divided by 2 is just going to give us 1, or 1x. Bring down your equal sign, and 10 divided by 2 gives us the number 5. So x is equal to 5. Let's look at the next one. M minus 5 equals 17. M minus 5 equals 17. The inverse of this minus 5 is plus 5. So whatever I do to the left, I also need to do to the right side. I bring down my m value. This minus 5 plus 5 are going to cancel each other out. Equals, and 17 plus 5 gives us 22. M is equal to 22. Now this next one, it says 2/3 y equals 8. 2/3 y equals 8. And the 2/3 and the y are being multiplied together, so that just means we would need to divide by our fraction. But if you'll remember your multiplication and division rules for fractions, dividing a fraction by another fraction or dividing a value by a fraction is really the same thing as multiplying by its reciprocal. So this one is just a little bit different. I wanted to make sure we got an example or two in right here. So the reciprocal of 2/3, remember reciprocal just means we flip our fraction, is just 3/2. So we are going to multiply the left side of our equation by 3/2, which means we are going to multiply the right side of our equation by 3/2. And remember, when you multiply fractions, you multiply straight across. 3 times 2 is 6, 2 times 3 is 6. 6 divided by 6 would just give us 1. Or you can think, okay, well, when you're multiplying fractions, you can just reduce. A numerator has a number 2 in it, and the denominator has a number 2 in it. So those two reduce to 1/1. And then we have the 3's. We have a 3 in the numerator and a 3 in the denominator. So we're just left with 1y by doing that. Anytime you multiply a fraction by its reciprocal, it reduces to 1. So then we have 8 times 3 over 2. I am just going to put this whole number 8 over the number 1, and now I have two fractions that I'm multiplying together. 8 times 3 gives us 24. 1 times 2 gives us 2. Or you can go ahead and reduce before multiplying. I see that both my numerator 8 and my denominator 2 are divisible by the number 2. So when I divide 2 by 2, I get a 1. When I divide 8 by 2, I get a 4. And now we're working with some smaller numbers to multiply. 4 times 3 just gives us 12. 1 times 1 is 1. We just get 12. And then our last example here still deals with fractions. Let me move this over a little bit. 5 halves k equals 20. How do I clear a fraction? Just multiply by its reciprocal. 2 fifths. 2 fifths. There we go. All right. So when I multiply 5 halves times 2 fifths, those fractions reduce each other, and we are left with k equals, and I'm going to go ahead and place this 20 over the number 1. Now let's look. What can I reduce in a numerator and denominator? Well, this numerator is 20. This denominator is 5. So remember, we're always looking up and down. We're reducing numerators with denominators. 20 and 5 are both divisible by 5. So 5 divided by 5 gives us 1. 20 divided by 5 gives us 4. And now when we multiply 4 times 2, we get 8. 1 times 1 is just 1. So k equals 8. And that's solving one-step equations.